functions, which we haven't covered yet. Now, you see in Solidity there are setter and getter functions, and writing something, setting something, really needs a transaction which needs to be mined. And a reading function is simply called a call. Now, calls are against your local blockchain node you're connected to. You don't need to mine a transaction in order to read anything, because as you remember back, every participating node in the network has a copy of the exact same data, so you don't need to interact with any other blockchain node. You can just look in your local database what is the value that you are looking for, and it's virtually free. There is still some mechanism for gas included, but you don't have to pay for this gas because you would basically just pay it back to yourself, so that's all free. There are two different kinds of functions for reading values from a smart contract. The one is a view function, which is reading from state but not modifying the state and can call other view functions. And there are pure functions which are not reading or modifying the state, but they can interact with other pure functions. Now, both view and pure functions are relatively new. At the beginning, they were all called constant functions. So when you look at older tutorials or older Solidity files, then you would see function name, public, constant, and then return something. So the constant is replaced by view and pure to have a more granular idea about what this function is doing. Then we have function visibility. So far, we have worked with public and I believe external function visibility, but there are two more, which is private and internal. Let me tell you what this is about. So when you have a public function, then the public function can be called from outside of the smart contract and from within the smart contract, and it can also be called from any smart contract that extends a smart contract. So inheritance, if you work with inheritance, then you can call any public function from a smart contract that you extend. Private functions are only for within the smart contract. You cannot reach a private function from outside. So when you think of Remix and you mark a function as private, then the button will disappear that you can interact with this function. Same is true for if you interact with a function in the real world, then you would not be able to call this function. Also, private functions, you cannot interact with these private functions from derived smart contracts. So if you have inheritance, if you work with inheritance and you want to try to interact with a private function from a parent smart contract, it's not possible. External functions can only be called externally or from other smart contracts. You cannot call them from within the smart contract. Well, you can call them, but you would have to pretend that you are calling them from outside. So just keep in mind, external marks specifically functions which can only be interacted with externally, and internal functions are a little bit like private functions, but they work also within derived smart contracts. The constructor is a function which doesn't start with the keyword function, but with the keyword constructor, and then in the round brackets you have the function arguments. It is only called once during deployment, cannot be called afterwards, and a constructor is either public or it's internal, and so far we've only used public constructors that, well, face externally. A fallback function is a function without a name, so it starts with the keyword function but doesn't have a name. It is called under two circumstances. Number one is if you just send ether to the smart contract without interacting with any function, or if you try to interact with a function but you maybe misspelled the function name, and then the smart contract or the EVM cannot find this function in the source code and then automatically jumps to the fallback function. A fallback function can only be external. It cannot be public or internal or private because it's always externally facing. If you are trying to just send Ether to a smart contract without any function that you want to specifically have the user interact with, then you can define this in a fallback function. If you are trying to send Ether to a smart contract without a fallback function and none of the functions match your function definition, then it will throw an exception. So you cannot just send Ether to a smart contract without a fallback function that is meant for receiving Ether. The thing is, you cannot completely avoid receiving Ether, even though you have completely disabled all payable functions and know where you can receive Ether. There are at least two ways, actually three ways to receive Ether on a smart contract. Number one is if you self-destruct another smart contract and you have the address of your smart contract as the beneficiary, then you will receive the Ether no matter what. It will be credited. The second thing is if you do mining and you let the miner send the miner's reward to your smart contract, and you will receive this Ether no matter if you want it or not. It's not going to throw an exception there. So it's not going to reject this Ether. And the third one is if you are sending Ether to the address of a smart contract before the smart contract is deployed, then you will have already Ether there before the smart contract is there. And this is why you should not, under no circumstance, ever try to match the balance in a variable that we have a balance received, this mapping, to the total balance of the smart contract, and then like have an assert that this is the same for all people who credited Ether, because this can go wrong in a very bad way. So the thing is, with fallback functions, in the worst case, you can only rely on 2300 gas. It's called the gas depend. So when you have, when you use the transfer function inside your smart contract and you transfer to another smart contract, then it will only send 2300 gas along, which is not a lot. We are talking about this in a different lecture about gas. Just keep in mind when you are designing wallets or something like this, that in your fallback function, you are not doing too many computational operations. If somebody sends, or if somebody is trying to interact with your smart contract with a function that doesn't exist, or with a function with the wrong amount of arguments and so on, then you can forcefully prevent the contract execution by just checking that the message data length is 0. That would mean that only people who send money to the smart contract can do that, and if they accidentally try to interact with a function that doesn't exist, then it will fail. Okay, the key takeaways, that was long enough. The constructor is called only once. Keep that in mind. A fallback function is here mostly to receive Ether in a simple transaction. Beware of the gas limit, which we are talking about later. The getter functions, they are usually view functions. Seldom I've seen really pure functions. And view and pure or constant functions are only against your local blockchain node. They don't need to mine, so they are instantaneously having the result.